All right, good evening, pre-calculus students. So we're going to talk about our quiz review for quiz 6 here. And I guess we should probably just get started, eh? Okay. All right. So what we're going to talk about is we're going to graph and polar coordinates. We are going to do some vector addition, some dot products, and the Mom's theorem. Now, this formula is given. Okay, so you don't have to memorize that. All right. So let's go ahead and get into it. So graphing and polar coordinates. Okay, graphing. So I'm going to give you a formula function a plus or minus b sine theta, or a plus or minus b cosine theta. Okay, it's going to look something like one of those things. All right, I'm not going off through bounds and showing you all kinds of weird stuff in polar coordinates. We're just going to pretty much take the basics and we'll go with that. All right. So let's see here. Why don't we pick something like 4 plus 5 cosine theta. Okay, we'll start with that. So what we're going to do here, write that down a little bit here. Okay, what we're going to do is the first set of instructions you're going to receive, okay, with this. Step 1 is to graph the function on an r theta Cartesian axis. Okay, just like the standard x and y axis you've been dealing with. All right, so all I want you to do is graph cosine. Okay, 4 plus 5 cosine. All right, so here's my coordinate axis. Okay, mostly it's going to take place over in the top here. I'm going to go ahead and put a baseline down. 1, 2, 3, 4, 5. Oh, we're going to need a lot of room. I'm going to need up to 9. Okay, so we need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so here's 4. So the reason why you wanted to do 4 was because really this is a cosine with an amplitude of 5, but a vertical shift of 4. Okay, so I'd really rather put my baseline here, and I'm just going to pretend this is my axis because it's at 4. Okay, so we're going to put in a 2 pi over 2 and a 3 pi over 2. Okay, so at 0, okay, we're going to think, well, what happens with cosine? Well, cosine at 0 is 1. Right, so we put a 1 in here. So 4 plus 5 is going to be 9. So my first cosine value is going to be up here. Okay, and then we go to pi over 2. Pi over 2, cosine of pi over 2 is 0, so we just have 4. Okay, we go to pi. Cosine of pi is -1, so we have 4 minus 5. That's going to be -1. Okay, 3 pi over 2, again, that's back to 0 for the cosine. And then at 2 pi, we're going to be back up here. Quick, cosine of 2 pi is 1. 4 plus 5 times 1. 4 plus 5 is going to be 9 again. Okay. So when we go to graph this thing, I'm just going to ask you to pretend that it actually has all the dots, okay, that we have sitting here for cosine. Now, we're going to go ahead and start graphing the polar coordinate form now, okay? So the reason why I want to do it this way is because where does it go underneath? Where does it go under? Where does it go negative? That's the problem, okay? So what we're going to do, okay, is we're going to need 9s. Okay, so at cosine equals, at theta equals 0, okay, that's straight across the line here. This is theta equals 0. Okay, we're going to be all the way out here at 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're going to be all the way out here at 9. Now what happens, okay, as we think about, cosine going from, or the angle going from 0 to pi over 2, what's happening to my r? My r is shrinking from 9 down to 4. So it's going to go 1, 2, 3, 4. Okay, so it's shrinking down to 4, going from 9 all the way out here, okay, all the way back down to 4 here. Okay, now on my direction here from pi over 2 to pi, what's happening? Okay, well, it's getting even smaller, right? It's getting even smaller. So to the point where actually it crosses the axis and it goes negative somewhere in here. Okay, and then it goes negative. So even though I'm going to be looking at pi, my value for pi is going to be 1, it's not really going to be 1 because it's 1 here, but it's actually negative 1, so it's in the other direction. Okay, so we're going to have a little piece here, and it's going to do something like that. So it looks like a little uvula or something. It's a little piece of the back of your throat. And then we're going to be going back to positives, and when we get down here to 3 pi over 4, 1, 2, 3, 4, okay, get down to 4 here, our function value is going to be coming back up here. Okay, and then from 3 pi over 2 to 2 pi, so third quadrant, I should say fourth quadrant now. So fourth quadrant stuff, it's going from 4 all the way out to 9. Okay, so here's 4, and it's just going to keep getting bigger and bigger and bigger up till 9. Okay, and that's what you want to do to graph this thing. Okay. So there's 2 parts here. There's a graphing it on an r theta Cartesian coordinate. Yes, you have to do this. Okay, and then secondly, we're going to graph this graph onto our polar coordinates. Okay, let's do one more. Let's do a 2 plus 2 sine theta. Okay, all right, so 2 plus 2 sine theta. So again, we're going to come up with a Cartesian coordinate system. Here's my r theta Cartesian graph. All right, and we're going to have a little baseline here at y equals 2, because again, it's just a sine, and then we've got a vertical shift there. So the sine's just going to dance around our y equals 2 line here. Okay, so here we go. We have a 2 pi. Here's a pi over 2, 3 pi over 2. Okay, we just have to remember that the amplitude is 2. Okay, so here at 0, right, sine of 0 is 0. Okay, and we're going to move up and back down over here. Okay, I should probably move that over a little bit. Okay, so we're just drawing a sine graph. It's a little bit stretched out because of the 2 here, and it's just shifted up by 2. That's all we're doing. Okay, 3 pi over 2, that's going to be -1, so we'll have 2 minus 2, and then back here. So we're just going to do a little sine wiggle dance here. All right, and there we go. So now what we're going to do is we're going to take this Cartesian graph and we're going to turn it into a polar graph. Okay, so what we're going to do is just going to come out here. Okay, now when theta is equal to 0, sine, right, r is going to be just 2. And so we have 1, 2. Okay, and then as we sweep up, right, from 0 to pi over 2, what's happening to my graph here, right? What's happening to my r? R is getting a little bit bigger. It's moving up to 4. Okay, so we have 1, 2, 3, 4. So we go from 2 up here to 4. All right. And then we come back down. So we are at pi, and that's over here. The sine of pi is 0, so r is simply going to go back to being 2. Okay. And then we get to 3 pi over 2, right? That's going to go to 0. So what's going to happen is we're going to come out here, right? And then come in. Because at this point here, it's 0, so it's going to touch the origin. Okay, and then it just touched 3 pi over 2. So now it's going to be not have 3 pi over 2. Okay, don't judge my graph too harshly. Okay, and we're going to go back up to 2. All right, so that's how you graph 2 plus 2 sine theta, r equals. Okay, so that's the kind of thing you're going to want to be able to do. Right? When you get to Calc 2, because that's what this was really for. Actually, most of the classes in preparation for Calc 2, so sorry for the misnaming here. But Calc 2, you're going to do polar coordinates again, and they're going to do things like graph, or what's the area in this little lobe thing right here? Okay, that's why you have to know how to graph this stuff. Okay, even if like, well, just use the calculator. Like, there's a time and a place, all right. But if you have to remember, if you have to go through the calculator and deal with all of this, I mean, sometimes it takes longer than it's worth to do it with calculator. Okay, if you have something complicated, use the calculator. But if you have something that's pretty straightforward, just go ahead and graph it. And then, depending on, because it's going to be up to you. They're going to say, well, where is this? And you're going to have to go, well, here's my angle to my angle over here. Okay, so we're going to have to integrate. We're going to have to figure out the area here between pi and the 3 pi over 2. And graphing is going to help you know that. Okay, it could get a little worse. They might put a circle in here and ask you to graph the stuff that's in the circle or whatever. But that's, for the most part, that's what you're looking at. If they're more complicated, again, please just calculate if they're complicated. But if they're this shape, there's no reason for you to be using a calculator. You don't need to go to do that. All right, you should be able to do that by hand, just to get a quick sketch of what's going on, so you can go and do your calculus problem. Okay, and they'll reteach you some of this stuff just in case you've forgotten. Okay, it depends on who you have, but for the most part, they'll go over this again. Okay, and then again, it'll be about this level. Okay, Calc 3 is do this 3 dimensions, so it gets worse. Okay, all right. So that's how you graph in polar coordinates. What else are we doing? Oh, we're doing Demoivre's theorem. Okay. So again, you're going to be provided with Demoivre's theorem. Okay, this is going to say like we have z to the n. Okay, so z being a complex number, so we could say that z is equal to r cosine theta plus I sine theta. We can certainly do that. But when I want to raise this to the nth power, the way we do that is we say, well, this is r to the n, so this is the magnitude, okay? And then we're going to have cosine of n theta plus I sine of n theta, okay? So they're not going to want it like this. They're going to want it back in rectangular form. So let's go ahead and do a little example of this. Okay, excuse me. So let's come up with a z. Okay. Let's come up with one that's not obvious. Well, maybe a little bit. Okay. So why don't we do something like how about we do something like square root of 3 plus I. Okay, and then let's raise it to something weird. Okay, let's raise it to something like the 5th power. Okay, so there's 2 ways to do this. One way is we could do something like this. We could say square root of 3 plus I times the 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 square root of 3 plus I. And then you get to FOIL all of this out. Okay. Now, as much fun as that sounds, there's a faster way. Okay, and I want you to do this. So what we're going to do is we're going to convert this to our r to the n. Well, we're going to convert square root of 3 plus I into an r cosine theta plus I sine theta. Okay. One of the nice things about Treg is if you forgot how to do something like this, okay, what we're going to do is we're going to say, well, we've got to go square root of 3, which is like 1.7-ish, okay, and then 1 in the imaginary direction. That's where my graph is. And we could draw a little triangle here by saying something like this is square root of 3, okay, and this is I. Okay, it's 1. Actually, it's not I, it's 1, but it's in the imaginary direction, okay? So how do I get the magnitude here, right? Well, we have square root of 3 squared plus 1 squared, okay, and take the square root. So we're going to say this is 3, square root of 3 squared is 3, plus 1 squared, okay? And then we're going to get the square root of 3 plus 1 being 4, and our r is equal to 2, okay? And now what angle do I want here? Well, you know, if I didn't know any better, I'd swear this was a triangle. So how do we get that angle? We need to relate an opposite, an adjacent, and an angle. It sounds like a tangent. So we're going to say the tangent of theta is equal to opposite over adjacent. Okay, so theta is going to be the inverse tangent of 1 over root 3, which is pi over 6. Okay, that's pi over 6. All right. Sorry, Kitty, who's about to go into heat if she's not already there. Okay, so now, right, we're going to go ahead and say, well, this is square root of 3 plus I. This is equal to 2, right, r, times cosine of pi over 6 plus I sine pi over 6. Okay, now I'm going to want to raise this thing to what, the 6th power? So we're going to take 2 cosine, no, not the 6th power, that's too easy. I think it was the 5th power, wasn't it? Okay, so we have cosine pi over 6 plus I sine of pi over 6, and this is all raised to the 5th power. Okay, so 2 to the 5th, that's 32. All right, and then we have cosine of 5 pi over 6 plus I sine of pi over 6, 5 pi over 6, and we're set. Okay, we're set. Now we have to convert it back though. Okay, so this is going to be 32. Okay. Cosine of pi over 6, that is going to be square root of 3 over 2. But where's 5 pi over 6? It's here, isn't it? Right? So that's going to be a negative square root of 3 over 2. Okay. And then the sine of 5 pi over 6, this is going to be plus 1/2. Okay, so we have 1/2 I here. Okay, so sine of this, right, there's 1/2 cosine square root of 3 over 2. Okay, and now we're just going to multiply through this. Okay, so 32 divided by 2, that's 16. So we have negative 16 square root of 3 plus 32 over 2 is, again, 16I. And there we have it. There's our de Moivre's theorem for a complex number. And again, this formula is given to you in the quiz. Okay, I wrote it down underneath the problem. Don't memorize it. Okay, it's really cool. I always thought de Moivre's theorem was like really special and magical because fundamental theorem of algebra will tell you like, hey, if I've got x cubed minus 1 equals 0, then x cubed equals 1, or x equals 1. The fundamental theorem of algebra says there's 2 more, right? There's 3 roots here to this polynomial. I found 1. What the hell? This tells you how to get the rest of them. Okay, we don't quite go into de Moivre's theorem. We don't quite go into de Moivre's theorem quite that in depth. But you could tell where the other 2 pieces are because you will know how to get the complex. They're not real, they're complex. Okay, but you can't find them. Okay, and you look in your book, and there's a much more complicated formula to get, like if raised to the n, you have to raise to the 1 over n. It's a much more complicated formula. That one, I have to look it up. Okay, but the fact is, like, you know, you ask fundamental theorem of calculus or fundamental theorem of algebra, you say, hey, where are the other roots? Like, I don't know. I just told you how many of them were going to be. It's not my problem. De Moivre's theorem lets you figure out the rest of them. Okay, for simple ones anyway. Okay. So that's always struck me as kind of a cool thing that we could figure out the rest of the roots. Okay, whereas you couldn't without trade, without this tool. All right. So vector arithmetic. Okay, like the Despicable Me reference to that, right? Vector is the main villain of Despicable Me 1. He's got both magnitude and direction. Young supervillain, he's going places. All right. So let's see here. Sorry, not for my jokes here. So what we have to do, right, is we have to come up with a couple of vectors. All right. So what's that going to look like? It's going to look like this. Okay, so we're going to have F1 is equal to, let's go ahead and make that a better vector. Okay. F1, this is going to be equal to 30 newtons at 40 degrees. Okay. Then we'll do an F2, okay, is equal to, let's go this one. All right. And we'll do a 40 degrees here. Let's do something different. I hate to do 30 degrees. Okay, how about 20 degrees? We'll call that 20 degrees. Okay, so we'll say that this is going to be 20 newtons at, well, that's not really 20 degrees, is it? Right, there's 90 plus 20, so it's really 110 degrees. All right, so be careful because the homework problem in your book does it this way. All right, and then let's go ahead and do this. We'll call this 10 degrees here. Okay, so we'll say F3 is equal to, how about we call this 25 newtons. Now it says 10 degrees here. It's not really 10 degrees, is it? We're going around to 270 degrees. That's going to be 260 degrees, isn't it? Okay, so just be really careful because I know that the problem that they gave you is not in the standard orientation for angles. You're going to have to make some adjustments. Okay, so what we're going to do is we're going to write this in component form. Okay, my vector symbol, though, this is the standard vector symbol, is they just draw a line. So F with a bar over it would be a vector for F. I teach statistics a lot, so this means the average for me, so I don't like doing that. Some people have really good penmanship. I don't. You could tell that they write their vectors like that with a little tiny thing on there. I'll die of old age by the time I got finished with the problem if I did this. So I just write half of it, okay, for my vector symbol. I think in England they use that because this means to bold whatever it's under. Okay. So what we're going to do is we're just going to sum these up component-wise, okay? So when you take your physics class, you take your engineering classes, you're going to have your sum of vectors is equal to something. Just remember that when you're adding up a vector, whatever's over here is also a vector. Okay, so if you've taken physics, we're in the middle of it. A lot of times for equilibrium, we set them equal to 0. I guarantee if you type in the 0 with the little vector over it, your engineering teachers are gonna find that impressive. They're like, oh, you actually know what a vector is. So just realize that sums of vectors have to equal vectors. Okay, so it's one of those things when you tell your teacher, like, I know what I'm doing. Just give me a good grade. All right. So F1. Okay, that is going to equal, we've got 30 newtons, right? And we need to get the x component. So that's going to be cosine of 40 degrees I hat, because that's our vector in the x direction, plus 30, okay? And then we have sine, 40 degrees and that's j hat. Okay, and these are all in newtons. Okay, vector 2, the F2. This is equal to 20 newtons times the cosine of 110 degrees. Now this only works if you put the vectors in standard position. Otherwise, I'd have to come up with this triangle, and the x part of this is going to be there's going to be the sine of 20 degrees. And I also have to put a negative sign in front of it because it's going this way as opposed to that way. Okay, so be careful with your orientations, be careful with how you're writing your angles. Okay, so plus 20 degrees or 20 newtons, and this is sine of 110 degrees, and this is j hat, and again, everybody's in newtons. Okay, and then we have F3 is equal to, what was this? This was 25 newtons. Okay, and then we have cosine of what was this? This was 260 degrees. See, the fact that cosine is going to be negative in the third quadrant, this is already going to come out to be a negative term. You don't have to keep track of positives and negatives if you just use the regular angles. Okay, 25, okay, sine of 260 degrees, j hat, and again, everybody's in newtons. Okay, and we're just going to add these up. I'm not going to add i's to j's, that's not right, but I am going to add i's to i's to i's, and then j's to j's to j's. Okay, that's how that's going to work. So what we're going to do, okay, you're going to be using this, you're going to be doing this arithmetic for a very, very long time, by the way. So, and you could have used radians, that's fine. I thought it was easier to use degrees, but you could use both, okay? So plus 20 times cosine of, oops, I want cosine. 20 times cosine, right there, of 110. I'm going to do one thing for us before we finish this. So this is plus 25 times cosine of 260. Okay, and this is all my I hat stuff. I'm going to do one thing before I press the equals button. We're going to check here. We're going to make sure that we are in degrees. Okay. So we'll go ahead and get out of that. So we have this, double checking to make sure I'm in the right spot here. Okay, and then we're going to get some horrific number. Okay, let's see. It kind of depends on what your units are. I don't think I put them in here for the problem that you're going to do. So for this one, let's go ahead and we'll say 11 point. If I wanted to go to 3 decimal places, right? This would be, if I wanted to go to 4 decimal places, this would be 11.79. Oh, 998, I guess it would just be 7. So 11.7997. And this is my I hat direction. Okay. So that's what we have. Okay. And now we're going to say plus, now we're going to add up all of our j hat stuff. All right. So we've got 30 times sine of 40 degrees plus 20 times sine of 110, okay, plus 25 times sine of 260. Okay. And then equals, I got what, 13 point, and we'll go 4 decimal places here as well. Okay, 0.4573, 4573. 4573, and again, this is in newtons, this is in j hat. Okay, and now we're effectively done. Okay, we have 11 point something I hat, so almost 12 I hats, we'll call that there. And then 13 point something j hat, so we'll call that there, and that is going to be our resultant. Okay, so if you think like, well, did you get the negatives? Well, let's look. 20 times cosine of 110. Okay, it automatically comes out that way. Okay, so you don't have to keep track of it separately by yourself. Okay, so here is my 11.7997, and then this value up here, that's 13.4573. How would I get the diagonal here? Right? Oh, it's triangle. So we're gonna have, this is going to be 11.7997 squared plus 13.4573 squared, and that's going to be the length of my vector. Okay, so we're going to have 11.7997, okay, plus 13.4573 squared. Okay, done. Square root here of 320 something. 320.3318. 0.3318. And we're just going to take that square root. All right, done. 17 point, how many decimal places do we have at the beginning of this? We had none. So let's go ahead and say 17.9 here for the answer. Okay. Okay. And how do I get an angle? Well, what function will relate an angle to an opposite side and an adjacent side? Oh yeah, tangent. So my value is going to be, right, tangent of theta is equal to these two values, right? Tangent of theta is equal to 13.4573 over 11.997. You guys remember doing this at the beginning? So theta is going to be the inverse tangent of 13.4573 over 11.7997. Okay, and again, we're in degrees. That's fine. It didn't say use it in radians, use it in degrees. They did the same. Okay, and if you're going to be an engineer, you're going to have to be able to go backwards and forwards with this, because if you're going to hire a contractor, you say, well, look, we need this building, and this angle here has to be pi over, 3 pi over 5 or something. That carpenter, that contractor is not going to be happy with you. 3 divided by 11.7997. So my theta is equal to, and again, we had all of one significant figure when we did this, so we're going to just do 48.8 degrees and be done with it. Okay, 48.8 degrees. Okay, so we have our vector, my resultant force, okay, is 17.9 newtons at 48.8 degrees. Okay, that's all I want you to do. So practice adding up some vectors. Again, it's good for you. The more practice you do, the easier it will be when you get to physics and other classes that are going to use vectors. Okay. So the last thing is to come up with, well, what is the angle between two vectors? Okay, and I'm sorry, I did not provide this formula. You're going to have to memorize this. Okay, remember what a dot product is, right? A dot product is U dot V is equal to U1 V1, right? The first component plus U2 V2. Okay, it is also equal to the magnitude of U times the magnitude of V, okay, times cosine theta. Okay, you're almost big enough for me to tell a math joke, but you have to wait till count 3. Okay, so this is a relationship. Okay, the dot product is equal to both of these things. It's two alternate ways to do it. What we're going to do is we're going to take these two, set them against each other, and then solve for cosine. So we have u1 v1 plus u2 v2 divided by the length of u, the length of v, okay, is equal to the cosine of theta. By the way, the dot product of two vectors is a scalar quantity. Okay, so once we've taken a dot product of these guys, these are all now scalars. Okay, so this guy here is a scalar. This multiplication is also a scalar. So we started off with two vectors. We ended up with a scalar. Okay, there are other kinds of vector multiplication that you end up with a vector. One of them is called the cross product. Okay, so that's what we have for that. Okay, so and those are pretty much the only two vector multiplication problems you're going to deal with when you hit 400 level or 500 level. Then you'll do off something else. Okay, provided you go in that direction. Not everybody does. Okay, so there we go. Let's look at an example. Okay, how about we look at the vector u will be 1, 8, and v will be about 2, -5. Okay, what's this going to look like? Well, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we're going to have 1, 5, 6, 7, 8. So we're going to be here. So I want this is u. Okay, and then we're going to have 2, 3, 5. Then we're going to have 2 here. Okay. Okay, so here's my v. You can't really do it by looking at it on the chart. You can add vectors that way because you can think about picking this one up and putting it over here, and getting an idea for how to add them. You'll make a little parallelogram. It doesn't work for multiplication. We're just kind of stuck. Okay, so u dot v is equal to 1 times 2, right? 1 times 2 plus 8 times -5. Okay, so that's going to be 2 plus -40, 4 times 5. So we're going to get -38. Okay, that's my dot product. And well, it's negative, but that's okay. All right. We also need to figure out what is the length of u and what is the length of v. So what we're going to do is we're just going to do Pythagorean's theorem again on it, right? That's going to be the square root of 1 squared plus 8 squared. Okay, for u, and the square root of 2 squared plus -5 squared. Okay, don't do this. When you have this -5 squared, it turns it into a positive. So this is 25 plus 2, or plus 4 rather, 25 plus 4 is the square root of 29. This one here, this is 64 plus 1, that's square root of 65. Okay, so just be careful about the signs, SIGN signs, when you're taking your products. Okay, so what we're going to do is we're going to say that the cosine of theta is equal to -38. That's what we calculated up here. You know, we've got a square root of 65 and a square root of 29. Since they're both under a square root, we can combine them. So this is cosine of theta is equal to -38 over square root 65 times 29. I don't think that's going to help. Okay, because 29, I believe, is prime. 65 is 5 times 13, which are both, this is going to use b. We're not going to get a simplified form. Okay, that's okay. So we're going to have cosine inverse of -38 over square root 65 times 29. Okay, and that's going to be the angle that is separating these two vectors. Okay, so not as bad as you might think. Okay, so we have -38 divided by the square root, okay, of 65 times 29. Okay. And I think we'll be okay with that. And now, since we're still in degree mode, we're just going to do second function cosine. Second function, my last answer, that's what this is. So you don't have to carry that number around. And we get theta is equal to 151. 0.07, we'll just say 0.07 degrees. Okay, and that's what we're asking for, is like, what's the angle between them? That's how you figure it out. Okay, so I think that pretty much runs through, almost everything. The face-to-face class had their most difficult time with polar coordinates. Follow the directions, make sure you've graphed them both. Okay. This one, some people had trouble with this, but since the formula is written down, I mean, if you've done one or two of your homework, it's the last problem in the homework on complex numbers. Okay, so it's the last one of the Moss theorem problem. We have to deal with all of this and then send it back to the original again. Okay. Vector arithmetic, there's one like that in there, maybe two, where you have to just add vectors up. Okay, so that's not so bad. Just have a system to do it, you'll be fine. Okay, and then back to arithmetic, the hardest part on this one is just memorizing the formula. You're going to have to do it someday anyway. You might as well do it now. Okay, so that's a good review for us. That gives you pretty much one sample problem of everything we have. I wish you the best of luck with it. Okay, and I hope everybody does well. All right, thank you much, and have a good evening.